In this video, we're going to continue our discussion on right triangle trigonometry. Specifically, there's one important topic that I'd like to discuss with you guys, and that is going to be finding the remaining trig values given one of the trig values. That sounds like a mouthful, but basically there are 6 trigonometric values that are given to us, right? And as you see here, we have the sine, the cosine, tangent, cosecant, secant, and cotangent. And just as a quick refresher here, if you have a right triangle with the angle theta here, then you have a side that is opposite of theta, you have a side that is adjacent of theta, and then you have hypotenuse, which is the longest side of any right triangle. If you need a refresher on this part, feel free to look at right triangle trigonometry, which is the first part of this video. This is the second part. So our goal is to see if we're given any one of these 6 trig values or ratios, how can we find the remaining 5? So let's get started. In this first example, given that sine theta is equal to 5 over 13, we want to find the remaining trig values. So using our knowledge of what sine is, right, in terms of a right triangle, we know that sine of theta is equal to the opposite over the hypotenuse. So op over hype, right? Or as we know, it's SOH, right, for the SOHCAHTOA mnemonic. So if we know that it's opposite of hypotenuse, then we know that 5 would be the opposite side over 13, which is the hypotenuse. Now, in order to understand this problem in a better light, we would then draw a model of the right triangle once again. I know it's not the best drawing. And here's my angle theta for standard. And I know my hypotenuse is 13, and the side opposite theta would be 5. That leaves us with a missing side right here, which we can then find with the help of the Pythagorean theorem. So as a reminder, that is a squared plus b squared equals c squared. All right, and just for the sake of this video, we'll call that missing side b. So I'll do 5 squared plus b squared equals 13 squared. And that 5 squared would give us 25. Then b squared, which is unknown to us, which is equal to 169. Then I'll subtract 25, or I could just move 25 to the other side, whichever way works for you. I'll do the moving around, and b squared equals 144. From here, I would then take the square root of both sides to solve for b, and b would be equal to 12. Now, using this information here, I now know that 12 is my missing side. Now I can find cosine of theta, which in this case is going to be adjacent over hypotenuse. And that's going to give me 12 over 13. Then you have tangent of theta, which is, excuse me, opposite over adjacent. And that gives me 5 over 12. And then you have the remaining 5, which is given to us also. Or the remaining 5 again. It is cosecant, so CSC theta. Cosecant theta is the hypotenuse over the opposite. And that's just the reciprocal of sine. So 13 over 5. And then you have secant of theta, which is the reciprocal of cosine, which is 13 over 12. But I'll just write hypotenuse over adjacent as well. 13 over 12. And then you have cotangent, the reciprocal of tangent. Oops, that's supposed to be cotangent. That's a T right here. Cotangent of theta would be equal to adjacent over opposite. Now that's going to be 12 over 5. All right, so that's essentially the goal of finding the remaining trigonometric values given one of the trig values here. So in this case, we were given sine. So then our goal would have been to find cosine, tangent, cosecant, and secant. All right, let's move on to the next example, a little bit more of a challenge. Now, if cosine was given to us and it's 5 over 9, then I know that cosine is equal to adjacent over hypotenuse, right? So here I can just deduce from here that this is 5 over 9. And if I draw my right triangle, once again, theta as an angle right here, I'll get the 9 as the hypotenuse and the 5 as the adjacent. So my missing side for this video will be A, but I'll just rewrite the Pythagorean theorem once again for consistency. A squared plus B squared equals C squared. And that gives me A squared plus, and I'll skip the step here, it's 25 equals 81. I'll move 25 to the other side, and that'll give me A squared. Whoops. That'll give me A squared equals 81 minus 25, which is 56. And if I take the square root on both sides here, A is equal to the square root of 56. However, as a quick refresher right here, if I want to know the square root of 56 and how it breaks down, I would then use a factor tree. And the best two numbers I can think of are 4 and 14, right? Now, 14 and 4 will just break down into 2 and 7. So they're both prime, but 4, on the other hand, square root of 4 becomes 2. So 2 square root of 14 is the square root of 56. And I'd rather leave it in its simplest radical form. So 2 square root of 14. So this missing side here is 2 square root of 14. Well, 2 square root of 14. Okay, now let's find the remaining trig values, and that would be sine of theta. I'm not going to write the sides anymore. We'll just do it from what we know. So sine theta is 2 root 14 over 9. And since the radical is at top, that is totally fine. Then you have the tangent of theta, which is 2 square root of 14 over 5. Then you have sine's reciprocal, which is cosecant. Cosecant theta, which will then be 9 over 2 square root of 14. But because we don't like the radical at the bottom, we're going to multiply the top and bottom by square root of 14. And that should give me 9 square root of 14 over 28. Then secant of theta is going to give me the cosine reciprocal, which is going to be 9/5. Hold on. Actually, wait, sine's reciprocal is cosecant. Cosine's reciprocal is secant. Oh yeah, that's right, 9 over 5. So there we go. I had a moment where I thought I was going to be wrong here. And then cotangent of theta is going to be 5 over 2 square root of 14. Rationalize, square root of 14 over square root of 14 would give me 5 square root of 14 over 28. Okay, and then if you look at the fractions for the cosecant and the cotangent, you'll notice that none of them can be simplified, so just leave it like that. That is your simplified radical form. Now let's do something a little bit more challenging here. If your cosecant of theta is equal to 4 and they want to find the remaining trig values, well, first, we know that the cosecant reciprocal was sine, and sine is given to us as opposite over hypotenuse, right? And so cosecant would then be given to us as the hypotenuse over opposite. But you're probably wondering, oh, there's just only a 4 there, right? But remember, cosecant of theta equals 4 can be rewritten as 4 over 1. So in this case, it's going to be 4 over 1 like this. And our right triangle again, we'll draw a standard right triangle. Again, theta right here. And because it's 4 over here and 1 for the opposite, we will find b in this case. So 1 plus b squared equals 16. And if we move the 1 to the other side, we get b squared is equal to 15, and then we square root it. So b equals the square root of 15. Now, going off on what we know about sine, we can just say that sine is 1/4, because it's just the reciprocal of cosecant. Cosine, on the other hand, is going to be, whoops, I forgot to write here, square root of 15. Square root of 15 over 4. And tangent will then be 1 over square root of 15, which then, if you rationalize, would give you square root of 15 over 15. Now the remaining ones would then be secant. Secant of theta would be 4 over square root of 15. And that's going to give you another rationalization right here, which is equal to 4 square root of 15 over 15. And then you have the cotangent, which is the last one here. Cotangent's reciprocal is just square root of 15 over 1, or you could just leave it as square root of 15. Okay, interesting problems, right? So hopefully this video gives you a better idea of what it means to find the remaining trigonometric values given one of the trigonometric values. This video also reviewed how to use the Pythagorean theorem to find the remaining side of a right triangle, as well as what were the 6 trigonometric ratios. So feel free to rewind this video, leave any comments down below, and hope to see you on the next video.